Okay, everybody, I'm here to help with the problem 5 on the homework set having to do with vector operations. So it says the city of Amsterdam in the Netherlands has several canals. You start at this point at some corner of Vondelpark, and then you've got 3 vectors. You sail 2.5 times 10 to the 3, it should say, meters, at about 60 degrees, 58.5 degrees north of east. So that north of east just means that the angle, from the horizon is up. Then you go 375 meters, not as far, 21.8 degrees north of east. And then another 875 meters, so a little longer than the second vector, at an angle as well. And it says, what would be your resultant displacement? Okay, so we got to break this down. I'm marking here the angles, so that first vector is 58.5 degrees from the horizontal. The second vector is 21.8 degrees from the horizontal. I say from the horizontal because in this case, to the right, that horizontal is east. Oh, it looks like I made a mistake on the last vector. This one, instead of drawing it 21.5 degrees up from the horizontal, is the other way because it's east of north. North is like straight up in this configuration. So if you go clockwise from north, that's east of north. And so that angle from the black line shown here, that angle is 21.5 degrees. Okay, so here we have these 3 vectors, the blue one, the red one, and the green one. And if you line them up this way, you can add them up. What's the steps? Well, the first thing you need to do is you need to find all of the x components. Okay? If you find the x components, you can then add them up. Do the same thing with the y's, and then use Pythagoras. So let me step you through finding the x component. For the blue vector, we'll call it a. In this case, a sub x, or the x component, is going to be a times the cosine of that angle. Why is it that? Well, the cosine is adjacent over hypotenuse, and in this case, the adjacent is the x component. The hypotenuse is the vector, a. So this turns out to be 2.50 times 10 to the 3 times the cosine of 58.5 degrees. That's going to be a sub x, or the x component. I'll leave that to you guys to figure out. And let's move on then to the second vector, the vector in red. So if you want to find the x component of the red vector, it's the same process. We'll call this b. So b sub x, or the x component of vector b, is b times the cosine of its angle. Why is that? Well, that's because b sub x will be the adjacent of a triangle made with b, and b is the hypotenuse. So then you get 375 in this case, that's what b is, times the cosine of that angle, and I'll leave that up to you as well. This last one, the green vector, it's going to be a little bit trickier because the angle isn't defined from the horizontal. But we can do that if we want. I'm going to do that. We know that if that angle is 21.5 degrees, then the angle from the horizontal, right, is the one that's north of east. And what we have is east of north. Let's put them together. Together they make 90 degrees, right? North and east are a 90-degree angle. So 90 degrees minus the angle we're given is the one that's north of east, or the same kind of angle that we used for vectors a and b. So in this case, I'm looking for that angle, the one shown by the kind of green arc there. 90 minus 21.5, probably do that in my head here. That's kind of like 70 minus 1.5, so it's 68.5 degrees. So you can continue the same process here and find the x component of vector c. So c sub x is just c times the cosine of this new angle we found, 68.5 degrees. Okay, you have to do a little math, right? That's 875 times the cosine of that angle. You can do that math, and what will you have? You'll have all of the x components. What do we do with those? Well, you're going to put them together. Because if I draw the resultant vector in purple, okay, from the start all the way to the end, that's the thing I'm looking for. To find that, I first need to find the x part and then the y part. We'll call that the resultant, right? The resultant is what I'm looking for. And if I want the length of that, I can add up all the x parts, right? All the x parts. And then I can use all the y parts and use Pythagoras. And we have just calculated all the x parts. So we can find the total r sub x, or the x component of the resultant vector. And that's simply r sub x is equal to a sub x, right, added to the x component of the b vector, which is b sub x, added to the x component of the c vector, which is c sub x. You figured out all those x's, add them together, and you get the total x.